Okay. They can hear me? Oh, okay. My bad. Hello, class today. I heard what's up and what is up. Oh. I get it. It's awesome. Hi class, today we are doing properties of real numbers. I need that page. All of the numbers that you use in everyday life are real numbers. Each real number corresponds to exactly 1 point on the number line. So all of these red dots are real numbers. 0, 2, 5, -2, -4, all real numbers. Fractions are also real numbers. -2 1/2 is a real number. The root of 2. Pi, all real numbers. Real numbers can be classified as either rational or irrational. Rational numbers can be expressed as a ratio, A over B, where A and B are integers, and B is not 0. B cannot be 0. A rational number cannot have B as the bottom of its ratio, as the denominator. The decimal form of a rational number is either a terminating or repeating decimal. Examples. The ratio form is root 9, decimal form 3.0. Ratio form 3 over 8, decimal form 0.375. Ratio form 3 over 7, decimal form 0.428571. A real number that is not rational is irrational. The decimal form of an irrational number neither terminates nor repeats. Pi is an irrational number. Pi equals 3.141592654, and it continues off into infinity. E. The exponent is also an irrational number. It continues on. It does not stop. It neither terminates nor repeats. So an irrational number continues. Do you notice a pattern within this group of numbers? Root of 2, root of 3, root of 5, root of 7, root of 11, and root of 13. Does anyone notice a pattern? They're all prime numbers. Prime numbers, they cannot be divided by anything other than themselves and 1. 2 can only be divided by 2 and 1, nothing else. 3 by 3 and 1, nothing else. 5 by 5 and 1, nothing else, and on and on. They are all prime numbers. Yes, 17 is also a rational number. Is also a prime number, as is 23. Relationships among the real numbers, sets and subsets. So real numbers, it's all of them. Q is rational numbers. I are irrational numbers. Within rational numbers are integers. Within integers are whole numbers. So here are rational numbers. Then a z are the integers. And then the w are whole numbers. So 1, 5, 8, 23. Integers would be 23.4. Irrational numbers over here. The square root of any whole number is either whole or irrational. For example, root 36 is a whole number, but root 30, since it lies between 5 and 6, must be irrational. Root of 36 is 6. Root of 25 is 5. But root of 30 is in between and thus is irrational. Whole numbers are rational numbers. So we can say that if it is not a whole number, if the root of the number cannot become a whole number, it is an irrational number. So what is the next root that would be a whole number? Yes? Oh yes. Correct. 16 goes in here. A whole number is a number without a fraction or a decimal. A whole number is a number without a fraction or a decimal. So 6 is a whole number. It is complete. It has no extra. 6. 5, 23, 16, those are all whole numbers. However, 6 1/2 is not a whole number. 4.3 is not a whole number. If it has a decimal point or a fraction, it is no longer a whole number. 1 is a whole number. -3 is a whole number. -1 is a whole number. -1.5 is not a whole number. So as long as it has no decimal and no fraction, it is a whole number. An integer is another name for a number, whereas so an integer could be 1 1/2 is an integer. 3.2 is an integer. Also, 4 is an integer. So an integer is just another name for these numbers, which is why we see the z is larger than the w. So whereas only whole numbers go inside this w, 1, 2, 3. Within this z would also include 1.5, 2.5. Those are integers. Okay. Whoa. So again, for example, root 36 is a whole number, but root 30, since it lies between 5 and 6, must be irrational. For the square root of any whole number is either whole or irrational. So the root of 36 is 6. It is a rational number. However, the root of 40 would be an irrational number. It is not a whole number. The next root to be a whole number Does anyone know what the next root that is a whole number is? If we had 16 is 4, 25 is 5, 36 is 6, the next number, the next root that would be a whole number, correct, 49. Because the root of 49 is 7. Anything in between root 36 and root 49 is irrational. It would not be a whole number, and therefore it would be irrational. It would... So here we see it on the number line. Root 25, 5. Root 36, 6. Root 30 is right here in the middle. The square root of 30 is 5.477225575, on and on. It continues on getting smaller and smaller. It does not terminate. It does not repeat. And again, if we had right here, we know that this is the root of 49. So if we had the square root of 40 here, the square root of 40 would be 6 point ... Continuing on, growing smaller, but neither terminating nor repeating. Do not assume that a number is irrational just because it is expressed using the square root symbol. You need to find its values first, because, as we see, certain roots are whole numbers. So if you assume that every number you see that's a root is going to be irrational, you will miss all of the ones that are not. Here's a list of common ones at the bottom. Root 4, root 9, root 16, root 25, root 36, root 49, and on. These numbers, the square root of 4 is 2, whole number. Square root of 9 is 3. The square root of 100 is 10. 121, 11. 144, 12. 169, 13. I think you see a trend. Although most numbers that are a square root will be irrational, not all of them are. If they can become a whole number, they are not irrational. These are all rational numbers. The real number system is an example of a mathematical structure called a field. Some of the properties of a field are summarized in the table below. For any real numbers, A, B, and C. For commutative addition, A plus B equals B plus A. It is the same. If A is 2 and B is 1, 2 plus 1 equals 1 plus 2. It is the same for multiplication. If A is 2 and B is 1, 2 multiplied by 1 equals 1 multiplied by 2. Associative. A plus B in the parentheses plus C equals A plus B plus C in parentheses. Changing the order does not change the answer. It is the same for multiplication. If we have A times B times C, it is the same as A times B times C. If A is 1, B is 2, C is 3, we have 1 times 2 is 2, times 3 is 6. Even if we change the order on the other side, A is 1, B is 2, C is 3. We have 3 times 2, 6. Multiplied by 1, 6. It is the same. Changing the order does not change the answer. Identity. A plus 0 equals A equals 0 plus A. When you add nothing to either side, you can change the order of the 0 being added. It does not change the answer. If A is 5, so say A equals 5, 5 plus 0 equals 5, 0 plus 5 equals 5. It does not matter where this 0 falls. It will give you the same answer. It is the same in multiplication. A multiplied by 1 equals A. A equals 1 multiplied by A. It does not matter if it multiplies by 1 before or after A. It will always equal A. The inverse. A plus negative A equals 0. Negative A plus A equals 0. It is the same thing. If A is 2, we have 2 plus negative 2 equals 0, because this addition sign is crossed out by this negative, and you subtract 2 by 2 is 0. It's the same on the other side. If A is 2, we have negative 2 plus 2, and negative 2 plus 2 equals 0. For multiplication, for the inverse, it is the same. As long as A does not equal 0, because remember, the denominator of a ratio cannot be 0, then A multiplied by 1 over A equals 1. This A will cross out. And it is the same with 1 over A multiplied by A. The A still cross out, leaving the 1. The last one is distributive. A times B plus C equals AB plus AC. You will multiply this A first by the B, giving you AB, and then you multiply the A by the C plus AC. And it is the same if the parentheses is before the A. So you can multiply A times B, BA plus A times C, CA. It is the same. It does not change the answer. That's the end of the slideshow. Are there any questions? You can type any questions to me. No. No questions. Okay, we're going to go back over the terminology really quickly. Okay, so again here, we have real numbers, all numbers that we use, both rational and irrational. All numbers are real numbers. And then right here we have rationals are the Q, irrationals are the I. Remember, rational numbers end. They stop. They can be whole numbers, they can be fractions, they can be decimals, but they stop. So a whole number is 3. A fraction is 15 and 1/2. A decimal is 6.35. All rational numbers. An irrational number, pi. 3.14 dot 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 dot. It continues on. The root of 30. 5.6 dot 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 dot. It continues on. It does not stop. It continues on and on. Within the rational numbers, we have integers, which refer to numbers, fractions, decimals. Integers. Within integers, we have whole numbers, which are numbers without a fraction and without a decimal point. So 16, 5,000. Integer, 5,000 and 1/3. The square root of any whole number is either whole or irrational. If it's a whole number, remember, it's a rational number because whole numbers are right here with the W. And if it does not end, it is irrational. So it is either a whole number or an irrational number. Here's the number line. And remember, for the common misconception, you may assume that a root is going to be irrational, but it is not always irrational. Some square rooted numbers can become whole numbers. Here's the list at the bottom. Root 4 through root 169 of ones that will be whole numbers. And there are more. Okay, real number properties again. Briefly went over. For any real number, A, B, and C, we have the commutative, A plus B equals B plus A. Multiplication, A times B equals B times A. Associative, A plus B plus C equals A plus B plus C. Multiplication, A times B times C equals A times B times C. Identity, A plus 0 equals A equals 0 plus A. Multiplication, A times 1 equals A equals 1 times A. Changing the order again for real numbers will not change the answer. A plus negative A equals 0 equals negative A plus A. Having this negative number on either side does not change the answer. And as long as A does not equal 0, A times 1 over A equals 1 over A times A. And then for distributive, A, B plus C distributes out to AB plus AC and equals B plus C times A, BA plus CA. Any questions? Anything that you need clarified? Nope. Well, sometimes they type no. I got one no. Okay. Okay. They're having a party upstairs. Pop quiz. What is this number? No. Is that an emoticon? No questions. You wanna know where I'm from? My name. What I like to do on a Saturday night. My favorite movie. Okay. Really? Someone be my friend. I'm very lonely. My students just create relationships with the other white teachers there. They're like, you and teacher Bex. I'm like, not dating. They what? Mine do too. There's one math teacher that they're dead sad about me dating. They're like, Teacher Oi, she's so pretty. Okay, no. Yeah, the first time they suggested me and Teacher Oi, I was like, Teacher Oi doesn't speak English. There's gonna be a problem. Hello. Okay. Okay, an integer. Let's go back to a different slide. Yeah. I'm trying to go back to slide number 1. And integers. Okay, again, we're going to briefly go over whole numbers versus integers. A whole number is a complete number with no fractions or decimals attached to it. So a whole number, no fractions or decimals. All of these numbers listed are whole numbers. 1, 2, 3, 16, 5,000. Whole numbers. An integer can have a decimal point or a fraction. So 1 and 1/2 is an integer. It is still a number. It is still on the number line. It is still a specific place, but it can have a fraction attached. 1 and 1/2. 2.5. 2.00 is a whole number. Correct. 2.00. There's nothing there. It is a whole number. If it was 2.5, it's an integer, not a whole number. 2.1 is an integer. Correct. 2.2, integer. 2.3, integer. 2.4, integer. 13.1, integer. Correct. A whole number cannot have a fraction or a decimal attached to it. If it is a whole number, there is no fraction or decimal. An integer can have a fraction or decimal. 1 and 1/2 and 1.5. It's an integer. It is not a whole number. An integer is a broader term. It's a larger term. A whole number is an integer. So you wouldn't say an integer have fractions or decimals, but a whole number doesn't have. That's correct, because a whole number does not have a fraction or decimal, but a whole number is also an integer. It's just going to confuse them further. $35 is a whole number. Okay. Right here is a number line. 1, 1.5, 1.7. Whoa. Does anyone know why this is happening? Are we done with this topic? Do they understand?
They kind of understand the theory, but they need more examples.
Okay, I'm trying to draw a number line, but it keeps changing the slide. Here we go. Okay. So here is a number line. Okay. Everything listed, all of these are integers. Everything on the number line is an integer. However, only the numbers without a decimal point are whole numbers. So 1, 2, and 3 are whole numbers. Inverse again, please.
They don't understand what is inverse.
Oh. Uh-oh, that's a different slide. So the inverse refers, let me open this slide up. It refers to the negative of A. So inverse is adding in the negative into these real number properties. So the inverse of A is negative A. The inverse of 2 is negative 2. So the inverse is...
This guy N has a question. He raises his hand. N.
Yes.
Can you ask N what does he want?
N, do you have a question?
Yes.
If he's talking, I can't hear him.
Is he talking? Hold on. Okay, N can talk now.
N.
Hello, พี่เต้เองเมื่อกี้น้องเอ็นมีคำถามป่ะจะถามอะไรกูไหมครับ he said he just clicked that พี่เต้เองมีใครมีคำถามอะไรบ้างไหมนะครับมีคำถามบ้างไหมของครูไหม
Tell him now he has to ask a question.
เย้ มีคำถามไหมครับคำศัพท์เยอะคำศัพท์ตรงไหนไม่เข้าใจหน้านี้เลยอ๋อSomeone has questions about
Okay.
this. You might have to go through the.
We can
research
clear
topic.
this.
Yeah, maybe you want to.
Okay.
Yeah, just click.
Oh,
X.
let me go to the next one so we have... Actually, let me go to the last one so that none of these are up. There we go. Okay. We're going to go back over real number properties. Addition and multiplication. These are the 5 different properties. And this is an equation for the property. So for commutative, all it says is that A plus B equals B plus A. If you change around the order, it will not change the answer. If A equals 5 and B equals 10, we have 5 plus 10 is the same as 10 plus 5. The commutative property for addition states that A plus B is the same as B plus A. 5 plus 10 equals 10 plus 5. Changing the order of these integers will not change the answer. It is the same for the multiplication. Again, if A is 5, B is 10, 5 times 10 equals 10 times 5. Both sides equal 50. The order of these two integers, for these two real numbers, will not change the answer. Are there any questions on the commutative?
Ow. ครูไม้ถามมีคำถามบ้างไหมเกี่ยวกับเรื่อง community ฮะมีคำถามไหมถามเลยนะพี่เต้คุมอยู่นะถามเลยครับถามเลยเดี๋ยวหรือว่าเก่งกันหมดเลยเก่งหมดเลยเดี๋ยวออกข้อสอบเลยนะมีใครถามครูไม้อีกไหมเงียบฮัลโหลจะไม่มีใครถามเลยเหรอยังไม่ค่อยแม่นน้องเพิร์ดหมายความว่าไงคะยังไม่ค่อยแม่นตรงไหนแต่ไม่รู้ว่าจะถามอะไร They said like they are maybe sure but they don't know where to start asking like I guess maybe
Okay. So for the commutative property again, if A equals 1 and B equals 0.5, if you plug these numbers into this equation, 1 plus 0.5 equals what? Type an answer for 1 plus 0.5. Hello. Hello. The last class was all about answering. These ones just don't want to.
Well,
this is easy. Come on.
Easy.
Okay.
I think they have hard time on vocabulary. Yeah.
What is 1 plus 0.5?
เอา1 บวก 0.5 คืออะไรครูก็ถาม
Correct. 1.5. Thank you. 1.5. And what the commutative property says is that if you switch the order, it's the same answer. So if we, instead of saying 1 plus 0.5, we could say 0.5 plus 1 equals what? 0.5 plus 1 equals It's very similar to this one. Yes, 1.5. Thank you very much. That is what the commutative property is saying. That you can switch the order of A and B, and it will give you the same answer. 1 plus 0.5 is the same as 0.5 plus 1.
ซอยมาแล้วไม่ต้องกลัวนะเดี๋ยวมีสอนภาษาไทยเพิ่มสิ่งที่ครูไม้เขาพยายามบอกก็คือ A กับ B B กับ A มันเป็นสัญลักษณ์ community เนี่ยถ้าค่ามันเท่ากันเนี่ยบวกยังไงมันก็ต้องเท่ากันโอเค just need to help them มันคือคำศัพท์ไปท่อง I said it's vocabulary they have to memorize
Okay.
Okay, go on.
Now, for multiplication, for the commutative property, it is the exact same. If A equals 5 and B equals 10, what is 5 times 10? Type an answer, please. TT will. Give TT a sec.
5 times 10 แล้ว นี่พี่เต้อุตส่าห์มาเป็น PA ให้ด้วยนะเนี่ยแล้วตอบ
Correct. 50.
สอนนะ
5 times 10 equals 50. And what the commutative property says is that 10 times 5 will give you the same answer. Correct. 50. All this rule says is it doesn't matter the order, it will give you the same answer. I do not know why you typed 51/1. Oh. 51 minus 1. Oh, 51 minus 1. That was witty. Okay. Do we understand? Do we need another example? One more example. Okay. So, if A equals 2 and B equals 1, let's do 7. B equals 7, A equals 2. 2 times 7 equals 7 times 2. That is what the commutative property of multiplication means. Correct. Both sides equal 14. เข้าใจไหม A กับ B มันคือเป็นชนิดไม่ว่าบวกหรือคูณเปลี่ยนกลับไปกลับมาค่ามันต้องเท่าเดิมภาษาอังกฤษเรียกว่า commutative. Okay, perfect. Okay, let's move on. Yes, yes. Okay, finally they say okay. Now we have associative. Thank God. Yes. It's okay, only 5 more. For associative, same concept as commutative. A plus B in parentheses plus C equals A plus B plus C in parentheses. So, if A equals 1, B equals 2, and C equals 3, A is 1 plus 2 plus 3. So 1 plus 2 is what? What is 1 plus 2? Correct. 3 plus 3 for the C equals A is 1 plus 2 plus 3. What is 3 plus 2? Correct. 5. So we have 3 plus 3 equals 1 plus 5. Correct. Both sides equal 6. All this rule says is it doesn't matter the order of the real numbers. They will both equal 6. You guys are correct. It is 6. 6 equals 6. Even if you change these numbers for other real numbers, it will equal, both sides will equal the same thing. For multiplication, explain word field in first line, please. Word field. Oh, the word field. The real number system. So, a real number is an integer, a whole number, rational numbers, irrational numbers. The word field is just referring to all of that. It's the field. The real number system is an example of a field. So all real numbers is an example of the mathematical structure called a field. Field is just a general term applied to a structure. And the reason it's taught is because some of the properties of a field are summarized here. So these are properties of the real number fields. Real number field. They are rules that apply to all real numbers. Again? Okay. I'll repeat that. The field is a general term applied to a mathematical structure or a grouping of anything. So in this example, it's the real number system is a field. So real numbers include rational numbers, irrational numbers, integers, whole numbers. Everything is considered a real number, and a field is just a term that was given to that. The term is the field of real numbers. The idea of real numbers. The general grouping of real numbers is termed a field. And in this line, it says some of the properties of a field are summarized in the table below. So the real number field what is field? Like the definition? So if we go back a ways, what is field? Yes. Here we go. This, everything included below, is in the real numbers field. Everything in this box, everything in this box is the real numbers field. So rational numbers, whole numbers, irrational numbers, integers are all in the real numbers field. Real numbers apply to everything within this square. This square can also be called the field. Yes. So everything in the box is part of the real numbers field. Okay, should we go back to the properties? clear this out. Okay, back to the associative property. For multiplication, if we have A is 2, B is 4, and C is 6, that's going to give us a big number. A times B, 2 times 4 times 6 equals A times 4 times 6. If we plug in numbers for these letters, what this property states is they will be the same thing. So 4 times 2 is what? Two times 4. Correct. 8 times 6 equals 2. And what is 4 times 6? 4 times 6. 24, correct. Now 8 times 6 is what? Correct. 48. And 2 times 24? Correct. 48. That is what the associative property states. That the order can change with the same answer. It's the same as these past 3 that we've done. The order can change, and the answer will be the same. Now moving on to identity. For addition, A plus 0 equals A equals 0 plus A. So let's say A is 5. 5 plus 0, if you add nothing to 5, it stays 5. Just as 0 plus 5 stays 5. 0 can be added before or after A, and the result will not change. 5 plus 0 equals 5. 0 plus 5 equals 5. For multiplication, A times 1 equals A. 1 times A equals A. So if A is 5 again, 5 times 1 is 5. You're multiplying 5 by 1 by itself. 5 times 1 is 5. 1 times 5 is 5. The order does not matter. If you multiply 1 by 5, it is 5. If you multiply 5 by 1, it's 5. If you multiply 17 by 1, it is 17. If you multiply 1 by 17, it is still 17. The order does not change the answer. Okay, inverse. Remember what I said, that inverse is the applying of a negative to the number. So again, if A is 5, then we have 5 plus negative 5 equals 0. The inverse of A is the negative of A. And when you have a positive number plus a negative of the same number, they cross each other out. It's the same as 5 minus 5. And what this property states is that if you switch the order and have the inverse first, it will not change the answer. So if you have -5 plus 5, -5 plus 5 makes 0. The same way as 5 plus -5 does. Both of these equal 0. A number's inverse, which is the negative of that number, so the inverse of A is -A. The inverse of 5 is -5. The inverse of 14 is -14. That's all an inverse is, the negative of the number. And in this equation, it equals 0. Because a number added to its inverse cancels each other out. It becomes 0. Then for multiplication, as long as A does not equal 0, because remember, we cannot have a fraction with 0 on the bottom, A, if we have A is 5 again, 5 multiplied by 1 over 5 equals 1. This number cancels out each other. What you have when you have a whole number, 5, multiplied by 1 over 5, is you basically have 5 over 1 times 1 over 5. You can cancel out the 5's, and they become 1, and the final answer is 1. The reason is if you were to do the math for that problem, A is 5, you have 5 times 1 over 5. You multiply that out, 5 times 1 over 5. 5 over 5 reduces to 1 over 1 equals 1. So in addition, the inverse is the negative of the number. In multiplication, it is the number under 1. So in multiplication, the inverse of 5 is 1 over 5. The rule states that you can switch the order and do the inverse times the number, same answer. So 1 over 5 times 5. Again, 5 over 5 is what it would equal, which becomes 1 over 1, which becomes 1. Are there questions? I see a lot of tie writing. I think we should. Okay. Do you want me to stop there, or do you want me to do distributive really quick? Okay. Lastly, distributive. Just like the rest, all it says is changing the order does not change the answer. So when you multiply this number out, A times B plus C, you first multiply the first group. A times B is AB. Then the second group, A times C, AC. It will give you the same answer as if you put the parentheses first and the A afterwards. You would do A times B, A times C. If we want to apply numbers here, A is 2, B is 3, C is 1. A times B is 6, plus A times C, 2. What does 6 plus 2 equal? So this was 3 times 2, and this was 2 times 1. 6 plus 2? Yes, it's 8. No one actually said that, but that's okay. And again, over here, we have A times B, which again is 2 times 3, and C times A, 1 times 2. So we have 6 plus 2, again, equals 8. It's the same answer. Switching the order, having BA plus CA is the same as AB plus AC. Same answer. Okay, thank you very much. Oh, I was trying to say thank you during it.